Good day, everyone. Today, we will discuss the caffeine metabolism and its importance in daily life. Caffeine is the one of most widely consumed psychoactive substance in the world. It is naturally found in coffee, tea, chocolate, and many energy drinks. People consume caffeine because it helps increase alertness, improve concentration, and reduce feeling of fatigue. After consumption, caffeine enters the bloodstream and transported to the liver, where it undergoes metabolism through a series of biochemical reactions. Understanding caffeine metabolism is important because it helps explain how caffeine affects the body, why some people are more sensitive to the caffeine than others, and how caffeine influences daily activity such as studying, working, and sleeping. In this presentation, we will explore the metabolic pathway of caffeine and discuss the significance in everyday life.
Biochemical pathway of caffeine metabolism is called hepatic and demethylation pathway of caffeine. The main engine working here is an enzyme called CYP1A2, which breaks down caffeine by snipping off metal groups through a process called N-demethylation. As you can see from the highlighted box, the biggest pathway happens when the enzyme removes a metal group from the 3-position nitrogen. This is the dominant pathway driven by CYP1A2 enzyme. About 84% of caffeine goes down this route, turning into metabolite called paraxanthine. This is the chemical that increases lipolysis, meaning it releases fatty acid into the blood to give our muscles energy. Next, about 12% of caffeine has a metal group removed from 1-position nitrogen. This creates theobromine. Instead of waking us up, theobromine acts mainly as a vasodilator, which means it widens our blood vessels and acts as mild diuretic, which increases urine volume. Finally, a very small amount, only 4%, loses a metal group at the 7-position nitrogen to become theophylline. Even though this is a tiny amount, it is a potent, smooth muscle relaxant that specifically targets and opens up the airway in our lungs.
Okay, for now, I'm going to explain the relevance caffeine metabolisms to our daily life. So, in caffeine metabolism to our daily life, as we know, caffeine are used to extend our study sessions and to remove the exhaustions during a sport session. So, how does caffeine works in our body to improve our exhaustions to avoid sleepiness? So, for example, coffee. Coffee has one molecule which is caffeine, as we talk about here. So, caffeines are identical to the adenosine. What is adenosine? Adenosine used for? Adenosine is used for to send us exhausted and sleepy signals to our adenosine receptor to our brains. So, when caffeine is identical to adenosine, it binds to the adenosine receptor and blocking instead of sending the signals. It's blocking and do not send any signals to our brains, which improve our mental focus and avoid any exhaustions when we do something.
Our presentation on caffeine metabolism. So let's summarize the key takeaways such that caffeine is a powerful central nervous system stimulant that millions of people, including students and adults, to rely on daily to power up their whole day and reduce fatigue. So, biochemically, its journey through the body relies heavily on the liver's hepatic and demethylation pathway, driven primarily by the CYP1A2 enzyme. Caffeine is broken down into three essential primary metabolites, with each of them carrying out unique functions in the human body. Firstly, paraxanthine has the vast majority of this metabolism at 84%. It influences the lipid metabolism. Next, theobromine makes up 12%, and it affects our cardiovascular and renal system as a vasodilator and diuretic. Moreover, theophylline only comprises of 4% and plays a medical role as a smooth muscle relaxant. And last but not least, Studying the biochemistry of caffeine shows us exactly how microscopic of an atomic structure and enzyme interactions directly change our physiological responses from a single cup of coffee.